So in the previous class, we have seen the select from where clause, and we have seen the various where clause variations which we can do, like between or the other union and intersect like this. Now we move on to the SQL queries. In the SQL queries, when we apply any select or any project or any Cartesian product, it automatically it does not remove the duplicates. So if you uh, execute the select, that is a select row operation, and if you pass on the relation R1 and it give you all the selected horizontal rows, in this horizontal rows, if you have C1 copies of a similar tuple, it will be giving the duplicate. You can count the duplicates as a C1. So it says that automatically it does not remove the duplicates. Whatever duplicates are present in data, you will be getting through the select, this select operator. The same is applicable to the pi, that is a project operator. It also automatically does not remove the duplicates. Whatever duplicates you have, it will be displayed. If you are doing R1 into R2, that is a Cartesian product, and R1 has C1 copies, that is a 7 duplicates, and R2 has C2 duplicates, then finally R1 into R2 has C1 into C2 copies. Now look at one example that will clear our concept regarding the duplicates. In this R1, we have this two columns, A comma B. It has the value 1 comma A, 2 comma A. R2 has only one column, which is a C. It has the only three rows, that is 2, 3 comma 3. Now if you want to extract only B column out of this R1, this B column is this one. So it will be giving you this entry for two number of times. That means the duplicates are not removed. And if you do the Cartesian product of this pi B R1 with the R2, then both A will be participating in the combination. First A will be combined with 2 comma 3 comma 3, and second A will again be combined with 2 comma 3 comma 3. So you will be getting these 6 rows. So the default syntax of SQL, select from where, does not remove the duplicates. Now we will see the other set operation that you can do with the select. The first set operation is a union operation. What this union operation do? The union operation will take all the entries from first query and will take all the entries from the second query. You can say the union is equal to the OR. The OR says that all the data which is present either in A or in B or in both. So you can say it will take the union of all. You must see that in the union binary operation, whatever operation you are doing, उस operation में जो whatever is the column name, it is same in both. If you are doing A union B, the column of A is course ID and the column of B is also course ID. So you must be very clear whenever you are applying the set operation. Both side of the set operation should have the same column names, and the same, you can say the name of column should also be same, and the data should also be of same domain type or same data type. So this query is giving us all the courses which fall either in 2009 or in 2010. So whenever you want to implement an OR operation, you have to use the union keyword. Now, what is the intersect? Intersect is equal to this intersect, this one. It take only the common entries and it is equal to the AND operation. In this AND operation, left hand side of this intersect and the right hand side of this intersect, in both of the tables, it should have the same column name, that is a course ID here, and uh, you can do the intersect. It will take only the common entries between between this table and this table. So the query is like, how do you, what are the courses which are offered in fall 2009 and spring 2010? So you have to implement the AND operation, and then you have to use the intersect. So A intersect B. It will be giving you all the courses that run in fall 2009 and spring 2010. And if you would like to implement the minus operation, that is subtraction, the subtraction says that you want to find out some data which falls in 2009 but not in spring 2010. Means the data which is present in A but not in B. You have to use a minus operation, present in A, not in B. For this, you have to use a word except in the SQL. In this SQL, you have to write A, that is select all the courses which are offered in 2009, minus, that is except B, all the courses which are minus all the courses which are offered in 2010. So it will be giving you all the courses that run in 2009 but not in 2010. We will again see one of the operation which you can implement with the set operation. In this case, we want to find out the salary of all the instructor which are less than the largest salary. For this, you have to compare the data of a table with itself. We have seen the contents or the columns of the instructor table. In this table, we had the instructor ID and salary and the department name. So in this case, you have to compare the data of instructor with the other instructors. So you have to do the comparison of instructor table with itself. To do this, we have to do the Cartesian product between the instructor to the instructor. So one time you have to rename it as T, and in the other time you have to rename it as a S. And it will do the Cartesian product between instructor with instructor, means every row of instructor T will be combined with every row of instructor S. So this way you will be doing all the combination of T table with the S table, and you have to select all the entries whose T salary is less than S salary. Means it will be giving you all the instructors which are less than, whose salary is less than one or more employee salary. Say for example, in the salary table, if you have 100 rupees salary, if you have 200 rupees salary, and you have 300 salary, this first query will be giving you all the entries whose T salary is less than S salary. Means if this is table T and if you have the table S, this table S also has the 100, 200 and 300. The Cartesian product will combine first row with all the other row, means 100, 100, 100, 200, 100, 300. Then it will take 200. It will be combined with all the rows, that is 200, 100, 200, 200, 200, 300. Then third row will be combined with all the rows, 300, 100, 300, 200, 300, 300. So that way you will be getting the 9 rows in Cartesian product of T, S. Out of these 9 rows, you have to select all the rows whose T dot salary is less than S dot salary. If you do this, you will be getting up all the rows whose salary is less than maximum. So this will give you the entries whose T salary is less than S salary, means whose T salary is 100 or 200. but 300 will not come because it is equal to this. So you will be getting all the salaries which are less than maximum one, less than the largest salary. Now, if you would like to get the maximum salary, how would you get the maximum salary? You can get the maximum salary. You can get the maximum salary by subtracting how can you get the maximum salary? Maximum salary can be you can get by subtracting the whole entries. Whole entries are 100, 200, 300. If you remove the row 1 and 2 from 100, 200, 300, you can get this maximum salary. So we are doing the same. First, we are finding out the instructor whose salary is less than maximum. Then we are finding out all the salaries, that is 100, 200 and 300. Now you can subtract the second query. The second query will be giving you the result of 100, 200 and 300. And the first query is giving us the result of 100 and 200. It is giving you 100 and 200. Finally, this, if you subtract this from this, you can get the output as 300. So you will be getting up the maximum salary or largest salary. This union, intersect and accept word, what we have learned right now, these automatically eliminate the duplicates. If you do not want to eliminate the duplicates, you have to use a keyword all with them. Union all will not remove the duplicate. Intersect all will not remove the duplicate. Accept all will not remove the duplicate. Now we will see the role of the null values in case of the queries. How can you handle the null values? If in any rows, so the data, if the data is not known, you can get the null values there. But what will happen if you execute the query on the null value, how it handles? Say for example, you would like to find out the null entries in the salary column. To find out all the instructor whose salary is null, you can write the query as select name from instructor where salary is null. So that way you can directly use the keyword as null. It will be giving you all the rows whose salary is null. You can check for the null entries in any of the column. Now if you calculate if you do some or operation or and operation or not operation in the where clause, and if some of the rows are having the null values, how they are calculated? So you can see that if it is a null, you cannot perform the operation with the null operation. You cannot check 5 is less than null. It is unknown. It will be returning you the unknown, which is not known. Null is not equal to null. It is also unknown. Null is equal to null is also unknown. If in the OR operation, one part of the query is giving you true, or the another part of giving query is giving you unknown, which is a null. If it is a OR operation, you can see that in a OR operation, if you get one true, output is going to be the true. If it is false and the second is unknown, the output is going to be the unknown, because if the unknown is true, it can be a true. If the unknown is false, then it can be a false. So that's why it is unknown. Unknown or unknown is also unknown. The same is applicable to AND. If one is true and second is unknown, unknown can be true or false both. So the output is unknown. Anything is false, even if you combine AND with any unknown, it is going you the false entry. So output is known, that is the false. So that way you can see that the unknown entry will lead you the unknown output in many of the cases. Now we come to the aggregate functions. The aggregate functions allow you to do the aggregate on the columns. Say for example, you do many of the aggregate operations in the Excel sheet itself, where you can find out the average of a column, minimum of a column, summation of a column. You can count the values in the column. The same you can do in the database itself, in the SQL query. The main operation aggregate functions which are allowed in the SQL is AVG, which give you the average of value. After AVG, we will be passing the name of the column. So on a particular column, it will perform this aggregate function. Minimum aggregate function will give you the minimum value. The maximum aggregate function will give you the maximum value. The sum aggregate function will give you sum of the values. The count will give you the count number of values, how many number of values are present in the count function. So you can see that these aggregate function will take the set of values and output is a single value. Now, how can you perform the aggregate function on the SQL? You can perform the SQL aggregate function. You can use the aggregate function in the select clause, and you have to pass the name of the column on which you want to do the aggregate. Say for example, you would like to find out the average of a salary. So select average salary from instructor, and you can filter on the department name, that is a computer science. So it will be giving you the average salary of computer science department. Now I would like to count the total number of instructors who are teaching the course in the spring 2010 semester. So first you have to filter all the courses which are offered in spring and 2010 from this table, and then you have to count the number of rows which has been filtered. For the number of rows, if there are the duplicate entries, to remove the duplicate entries, you have to use the word distinct word, so that you can get only the distinct ID, and it will giving you the count, how many distinct IDs are present. So if you would like to count the number of rows, you have to use the count word. This count is an aggregate function. If you pass the star in the count, this star says that it is counting all the rows. So it will be giving you count star from course. It says it gives you all the rows present in course table. Star means all. With the aggregate function, you can also use the group by clause. What is the group by clause? The group by clause will create the groups for you. But on which column you would like to create the groups, you have to give the column name. Say for example, I would like to create the groups on the department name. So you can see this data. In this data, we have created the groups on department like this. If you use the group by clause, you have to note that in the select clause, you can use either the column name which is used in group by or a aggregate function. Other than this, you cannot use any other thing. Please note that I repeat, if you are using the group by clause and you are creating a group on a particular column, with this, in the select clause, you have to use only the column name which is used in a group by clause or any other aggregate function. Other than this, you cannot use any other column name. So we are finding out the average salary of instructor in each department. So in this, I would like to find out the average salary of biology department, then computer science department, then electrical engineering department. So it is giving you the department name and average salary like this. It is the output of this query. As we have seen that if you are using a group by clause, in this you can either use a department name in the select clause or you can use any other aggregate function. If you are using anything other than this, it is a wrong query. It will be giving you error. It is not allowed. Whenever you are using the group by clause, and if you would like to filter the groups, then filtering the groups, you have to use a clause which is a having clause. I would like to clarify the where clause and having clause. In the where clause, you can filter all the rows in the table, but in the having clause is applicable only to the group by, means whatever groups has been created by the group by, which are filtered by having clause. So where clause never work on the group by, having clause will filter your data for you if you are using a group by clause. So we will see the use of the having clause. In the having clause, we are creating a group on the department name and you are finding out the average salary. Now I would like to display only the filtered average salary which is greater than 42,000. So it will be having average salary greater than 42,000. This is a very important concept. How can you handle the aggregate function along with the null values? The null values are ignored by the aggregate functions. They are ignored. If in an Excel column, if some of the rows are blank, it is going to ignore for you. If some of the rows you have kept blank, in the summation, it will not be taking that blank rows for you. The same is applicable for the aggregates. The null values are ignored. If in a count star and if you have used some null values, all the rows with null values are ignored. Now we come to the nested subqueries. The nested subquery says query within query. In the query within query, you can use the nested subquery either in the select or in the from or in the where. In the select part also, you can use the subquery here. In from clause also, you can use the subquery here. In the where clause also, you can use the subquery here. Subquery means you can also use select from where at this place, select from where at this place, select from where at this place. So if you are using the subquery at the P means predicate here, where P, you can use it by B is a column name and you can write some operations like union, except, intersect, and then you can write the subquery. Otherwise, in both of the other cases, you can directly use the subqueries. But in case of P, you have to use the column name. Operation is intersect, union, or except, and then you can use the subquery like this. Now we will see how can you use the subqueries in the where clause. To use the subqueries in the where clause, it is used either to find the set membership. What is the set membership? The set membership says that you would like to check whether X is member of a set. Set, say for example, the set will consist of value 1, comma, 2, comma, 3. If the value of X is 1, it is a member of set. If the value of X is 5, it is not a member of set. So you can check the set membership if you are using the subqueries in the where clause. You can also do for the set comparison. The set comparison says whether the value of, say for example, 5 is greater than this set. So you can do the set comparison. 5 is greater than all the entries. So you will say yes, it is greater than this set. So that way you can do the comparison of sets. And you can also do the set cardinality as well. So we will see the example of set membership. How can you use the set membership in the where clause? In the set membership, you can see that in the where clause, you have to first embed your nesting subquery like this. This nesting subquery will generate some data. So this nesting subquery is generating the course IDs. You can see that set of course ID will be generated and they will make some set. And if you make some set, you can check for the membership whether this course ID is present in this set or not. So that way you can check the membership. Now we take one example. This example says that if you would like to find all the courses offered in 2009 and in spring 2010, we will write a query like you can find out all the courses from the section, and first part of the filtering you have done here, you are selecting all the rows which are in 2009. Now you would like to find all the rows for 2010. How can you do this? You can do this by adding a subquery. This subquery is giving you all the course IDs of 2010, and then you can find out whether this course ID is a member of this. It will be returning you true, and for which the values are returned as a true, that row will be extracted. So that way you can combine the two queries. The first condition and the second condition is in the form of set membership. The same query can be written, we have written it in by using the intersect operator. If you can retrieve, you can remind whatever we have taught you in the case of intersect. To implement the AND operation, you can use the intersect. Query 1, which is 2009, query 2, which is 2010, and the intersect. Same query can be written like this by using the set membership. Now we will see the another example of the set membership. The courses which are offered in 2009 but not in 2010. This query is same as the above, only the difference is that we have to check that it is not a member. So first part of the query is giving you the data for 2009. Second part of query is retrieving you the set of 2010, and if the course ID is not a member of this set, then it will be returning the true, and that row will be returned, that row will be displayed. Now to remove the duplicates, you can use the keyword as a distinct. Sometimes we do not want to, we are interested only in the distinct counts. So whenever we are using the count operation, many number of times we are interested into the distinct. So we have to use the keyword as a distinct. So this query is again on the same lines where it is retrieving the 3 columns and checking for these 3 columns in the set membership. Look at this. These three columns are checked for these three columns in the set membership. The sequence and the name of these columns are same as that of these one as we studied in the previous slide. But here we are checking for the four columns. It is again an example of set membership. Now we will do for the set comparison. For the set comparison, we are checking for the entries which are present in set. Set comparison can be done in two ways. The one is we can check only for at least one of the entry. We are interested only in the sum case. Sum means sum of the entries. The sum will says we will be checking if it is true for at least one entry, then sum will return true for you. If I say whether 2 is greater than this set or not, 2 is greater than this set or not, what do you say? It is greater than this 3, but it is not greater than from all the entries 1, 2, 3. So if it is greater than at least one entry, I would like to check at least one entry and I would like to return it as a true, then you have to use the keyword as sum. At least one entry, sum. If I would like to check with all the entries, then you have to use the keyword as a all. So the 2 is not greater than all, but 2 is greater than 3. So you have to decide what your query demands. If your query demands to check at least from 1, then you have to use the keyword as sum. If your query demands to check from all the entries in the set, then you have to use the keyword as all. So we will take the example of both. In this query, we have to do, look at this, find the name of all the instructor whose salary is greater than some of the instructor, at least one instructor in the biology department. So you are interested only in sum. This query can be written as if T.salary is greater than S.salary, department name is biology. We have seen this query earlier also, so I am not repeating it again. Instructor is compared with instructor itself. And at least one salary, if T salary is greater than at least one of the S salary, then it will be giving you the T name. The same query can be written with the set clause. In the set, you have to compare the salary greater than sum, and this subquery is giving you all the salaries of biology department. So if this salary is greater than sum of this set, then it will be giving you the output. Both of the queries are doing the same thing. Look at this. The second part of the query is first extracted from this. It will be giving you all the salaries from the biology department, and then it is checked if this entry is greater than at least one of the entry in this set, then it will be giving you the output. So we will see some of the examples of sum clause. Look at this. In this, if your set has 0, 5, 6, and you have to check 5 is less than sum. Sum means at least 1. So you can see that 5 is less than 6. At least 1, it will return you true. Then you have to check 5 is less than 0, 5. No, 5 is not less than 0, 5, so it will return you false. 5 is equal to some 0, 5, it will return you true. 5 is equal to 5. 5 is not equal to 0, 5. So 5 is not equal to at least one entry, which is 0. So it will return you true. The meaning to say the sum will be check for at least one. Then you have to check for all. The all will be checking for all the entries. In this example, look at the subquery. Select salary from instructor and the department name is biology. It will be giving you a set of salaries from the biology department. Now you would like to check a salary which is greater than all the salaries in this set. So it will be, you have to use the all. This query is asking you to find the name of all the instructors whose salary is greater than the salary of all the instructor in biology department. So biology department, all the instructor will be extracted here, and then you can check for the salary which is greater than all the salaries in biology department. So it depends on the query which is asked. If in a query you are asked with the sum, then you have to use the keyword sum. If you are asked with the all, then you have to use the keyword as all. Take some of the example for all. In the all case, 5 is less than 0, 5, 6. 5 is less than all. What do you say? Is it less than all? No, it is not less than all. The 6 is more. It is not less than all. So it will be giving you false. 5 is less than 6, 10 with all. Yes, it is true. 5 is equal to 4 and 5 both. No, it is false. 5 is not equal to 4 and 6 both. It is true. So you can see in the sum clause we checked with 1, and in all clause we are checking with all. The exist clause is also very important from GATE point of view. Many queries are asked on this exist. In this exist, as the meaning says, where this exists. If it is exist, means existence is present, it is not null. You can say it is not null, it exists. Does not exist means it is a null, means R is equal to 0. Now we will see its use in the SQL query. The exist also uses with the subquery. In this exist, you have to use it in the where clause. In the where clause, if you use the exist and this subquery is returning some output, some entries. If it is returning some entries, then it will return you the true for you. If it is not returning anything, if it is returning 0, it will return the false for you. If it is returning true, so in this in this where clause, first part will be it is a predicate. It will be giving you true or false, and second part is also a predicate, which will giving you true or false. If true and true, then output will be true. So the query is, you want to find out all the courses which are taught in 2009 and in spring 2010. We did the same query by using the intersect clause, and we did it with the membership also, in clause also. Now we are doing the same query with the exist clause. In the exist clause, the first part of the query is retrieving the result of 2009, and the second part of query is retrieving the result for 2010. But look at this, you have to check for the course ID here, because it has become a separate part of the query. Now you have to combine the T dot course ID is same as a S dot course ID. You have to combine these two tables, section and this section as S, and the section as T will be we will be doing the Cartesian product with section S and the section T. Out of this Cartesian product table, you have to take only the rows whose S dot course ID is same as T dot course ID, and the condition year is equal to 2010 and semester is spring. If it retrieves some of the data, it will be giving you true, and you can get the entries of 2009 and 2010. Where not exist is reverse of the exist, where it is checking the subpart of this query. If it return, if this subquery is returning uh, if this subpart of the query it is returning the null, if it is returning the null, uh, it will be giving you the true value. Does not exist. If it does not exist, so it will check for does not exist. Now we will see the unique keyword. The unique keyword will check for the duplicate tuples. The duplicate tuples, if you are not interested into the duplicate tuples, you can check, you can use the unique keyword. So you can see that the unique keyword will check for the subquery is returning the duplicate tuples or not. The unique will give you the true if it has no duplicates. It is unique. Then it will be giving you true. Again, this subquery is giving you some result. In this subquery, if all the course IDs are unique, then it will be giving you the true. And then it will be, if it is part, this part is true means it is returning this row. Find out all the courses that were offered in at most 2009. So you are interested in the 2009 year course IDs, and at most one entry exists, at most one course ID. If the course ID is duplicate, the unique will be false, so it will not be giving the output. Now we will see the subqueries in the from clause. In the subqueries in the from clause is where you can use the subquery in the from clause, and the subquery is returning some table. You can remember that in the from clause we used to write the table name T1, T2 or T3. We used to write the table name. But in this case, we have written a subquery which again is returning a table. You can see that this table has not been given a name, but this table has the columns department name, average salary. And from this table, you can do the same operation as you can select some of the things, select some of the columns based on some queries, as you can use the where, you can use the group, whatever you want. So we would like to find out average instructor salary from those department whose average salary is greater than 42,000. So it is asking you to first group it on the departments. So you have to first group the instructor table in the department name, and then department should give you the department name and average salary. Out of this data, I would like to filter all the data whose average salary is greater than 42,000. You can see that this average salary is renamed as a AVG salary. So AVG salary is greater than 42,000. That has to be filtered, and you can give the output as department name and average salary. Look at the another example. In the from clause, you have used this subquery. This subquery is returning a table. This table has two columns and it is grouped by like this. And then you can do the operation as You can display something by using the select clause. You can filter the rows by using the where clause. Here we are filtering the rows, but we are filtering from the rows which is created here. Now we will see the use of subquery in the select clause. We can use the subquery in the select clause like this select clause is returning some number, and you can display department name and some number. What is this number it is returning? Select count star. It is counting the rows from the instructor where the department name is same as the instructor department name. As so you are finding the number of rows which are extracted from these queries, and then you can display the department name and the number of instructors. In every department it will be displaying you the number of instructors, and you can see that whatever data you are extracting has been given a name as num instructors. So this query will be giving you two columns. One is department name and another column will be number of instructor, NUM instructor, and will be giving you the output as CSE has 10 instructors, mechanical has 20 instructors. Like this, you will receive the output. So whatever query is giving, you can rename it like this. Now we come to the modification of the database. To modify the database, you can do the deletion, insertion, or updation of some of the values. How can you delete the entries from the table? You can delete the entries from the table by using a simple command, delete from instructor. It will delete all the rows from the table instructor. Now, if you are interested only in deleting some of the rows, you can use the query like this. Delete from instructor where department name is finance. Means it will be deleting you all the entries of the instructor whose department name is finance. In the delete clause itself, you can use the sub-nested query in the where clause. In the nested query, in delete also you can use the nested query in from clause. You can use the nested query in where clause. In the where clause, you can see that you are using the nested subquery. This nested subquery is returning some results and you are checking for set membership. This nested query is returning all the department names in the building Watson. And if your department name is present in this set, then it will be returned, it will be deleted. So all the entries which are present in this set will be deleted. So it will be deleting you all the tuples in the instructor whose instructors are associated with the department located in Watson building. This is again another version where we are checking for this, using the set comparison operation. In this we are finding out the average salary and we are generating a set of average salaries from the instructor, and then the salary which is less than this set will be deleted. If your salary is less than this set, then it will be deleted. So it is deleting all the instructors whose salary is less than average salary of instructors. This average salary will be a single number. It will be, say for example, 50,000. It is not a set. It is a single number. If it could have been a set, With the set, you have to use either a sum or all keyword for the comparison. Single value can be directly compared with this word, but if you have the set of values, then you have to use the keyword sum or all to check for the set comparison. Now, how can you insert the values into the table? To insert the values into the table, you have to use insert into table name, and then you have to give the values. The sequence of values should be same as that of table definition, and the type of data should be same as that of you have defined the domain data type. Say for example, it is a name which is quoted in the single quote. Then course name, it is again a string type, varchar type. And department, it is again a string, then it is a number type. So sequence and the data type should match whenever you are inserting the data. Otherwise, it will give you an error. If you are not willing to use the same sequence, then say for example, I would like to give the sequence as CS437, then computer science, then 4, then database system. I do not want to follow this sequence. If you do not want to follow the sequence, you have to use the keyword, sorry, you have to use the column name. So it says first column name is course ID, second column name is title, third column name is department name, and fourth is credit. You can swap also. Department name can come here, title can come here, and you can swap the entries here also. So if order is not known to you, first use the column name, then insert the values like this. If some of the entries are not known to you, you can insert the null as well. Although the null is not, we do not encourage you to use the null, but if the values are not known, you have to use the null. With the insert clause also, you can use the select from. Means you can import the data which is extracted from one table to the another table. Here we are importing the data from the instructor table, and in the instructor table we had only 3 columns. So in 3 columns you can extract the data, but in the 4th column the data is not known. You can mention it as a 0. So these 4 entries will be inserted, or you can import, will be imported into the table student. You have to make it sure that student table should be defined as its first column should be the ID data type, the ID, second column should be name, third should be department name, and fourth should be the number type, where you can insert this 0 here. So that way you can copy data from one table to the another table. Now we will see for the updates. The update says that for some of the entries, for some of the columns, you want to update the data. To update the data, you have to use the command as a update one. In this example, you want to increase the salaries of the instructor. I do not want to increase the salary of all the instructors. You would like to increase the salary of the instructors whose salary is greater than $1 lakh. And for them, you want to increase by 3%, but for rest of them, you want to increase by 5%. So you have to update the salary column. And with this condition, how can you do this? You can do this by using update and the name of the table on which you would like to make the changes. Now you have to write the condition. In the first case, you have to change for the salary is greater than 1 lakh. So you have to filter the rows whose salary is greater than 1 lakh. The salary has to be updated. Salary will be modified with salary into 1.03. So it will update all the rows whose salary is greater than 1 lakh and will be increased by 3%. Now again execute the update command once more. In this case, we are filtering the rows which are less than 1 lakh, and then we can improve their salary by 5%. So you have to execute the update command for 2 times. To get rid of, to update for the 2 times, we can use this case clause. It can accommodate the different if then else clause. Different cases can be handled. In this example, we update the salary, update instructor set salary. This set salary is returning you the salary. How it is returning the salary? If your salary is less than 1 lakh, salary is returned as 1.05, as the salary is returned as salary into 1.03. This salary will be returned and you can update the salary like this. You can also update the entries, update the salaries. You can also update the salary by using the SQL queries as well. These SQL queries or the nested queries are returning you some values. Say for example, it is returning you sum of the credit. One value is returned. That value will be set as a total credit. So you can use the SQL to return a single value, and then that can be assigned to this one. Now I am starting with the next part, later part of the SQL queries. In these SQL queries, we will be learning with the different type of joins, views, transactions, integrity constraints, and authorization. Joining operations are required you. The joining operations are required you to join the multiple tables. One of the example of joining we have seen is as a Cartesian product. With the Cartesian product, you would like to combine the entries from the 2 rows, and then you can do the join. Generally, that join operation is performed in the from clause table 1 comma table 2. So automatically it will do the Cartesian product between table 1 and table 2. For the following examples, we will be using the 2 tables. One is a course table and the second is a prerequisite table. We will be joining these 2 tables, and you can see that these tables can be joined on course ID. Generally, we do the joining on the similar column name. So it will be joining it on the course ID on a similar column name. You can see that some of the entries are same. Bio is present here, bio is present here. CS 190 is present here, the CS 190 is present here. 315 is present here, but it is not present here. CS 347 is present in this table, but it is not present in this table. If we consider it as the left hand side of table, and if this is a right table, and if you would like to perform the join operation in between 2, To join these two tables, the different type of joins are defined. One is the inner join. The inner join says that you have to work only on the matching values between two tables. In this case, the matching values between two tables is Bio 301 and CS 190. Means we are interested only in the common entries or the common areas. The next type of join is a left outer join. The left outer join says the data which is present in left hand side of table but not in right hand side of table. So you have to take all the entries of table 1, and out of this all the entries in table 1, if you take a match from right hand side of table, for the common one you can get the match, but for the entries which are present in left you cannot get the match. Look at this. It is a left table. You have to take the entries from the left hand side table. This bio will be combined with this bio. CS will be combined with this CS. But for CS 315, we do not have its match here. So you will be in the left outer join. All these three rows will come. All the rows which are present in left table. In the right outer join, you have to take all the entries in right hand side table. In this example, in right hand side table, all the entries are bio, CS and CS. So you have to take all the entries in right hand side table. The full outer join will take all the entries which are either in left or in right. You can say it is a union of all. Now we will see the outer join again with the same one. If it is a left outer join, you can see that how can you write the left outer join? You have to write it as a natural left outer join. In the natural left outer join, finally your table will be combining all the columns: course ID, title, department name, credits, and prerequisite. So look at the previous one, credits and prerequisite. This course ID will not be repeated. So these entries will come in the combined table. We are doing the combination as we do in the Cartesian product. And then in the left outer join, you will be taking up all the rows which are present in left hand side table. So the rows which are present in left hand side table, if its match is present, you can see that bio 301, the prerequisite of bio 301 is bio 3101. Prerequisite of CS 190 is CS 101. The prerequisite of 315 is not present. So you will be writing null. 315, prerequisite of 315 is not present. You will be writing null. Now we will see the right outer join. In the right outer join, the combined table column name is same as that of the previous one. Now we are taking only the entries which are in right hand side table. Which entries are present in right hand side table? Bio 301, CS 190 and CS 347. For Bio 301, the title is genetics, department name is biology, credit is 4, prerequisite is Bio 101. For CS 190, this title is this, department name is computer science, credit is 4, prerequisite is CS 101. For CS 347, the title is not known, you will insert null. Department name is not known, you will insert null. Credit is not known, you will insert null. And the prerequisite is CS 101. For right hand side, you can see the table like this. The entries which are not known, you have to write it as a null. And prerequisite is known. In the join operation, you have to first write what type of join you would like to use. The join type can be inner join, left outer join, right outer join, or full outer join. In addition to the join type, you have to give the condition to join, on what column you would like to join, on what predicate values you would like to join. Now we will see the full outer join. In the full outer join, you will get all the entries. First, the entries which are common in left and right both table. Then the entry in left hand side table whose right hand side is not present, so null. The entry in the right hand side table whose left hand side is not present, so null. And then it is combination of all. So full outer join is giving you all the entries like this. Now we will see the difference between the natural join and inner join. The inner join and the natural join are also different. How it is different? In the natural join, the common entries are automatically combined. The common values are automatically combined. You need not to give explicitly the condition for combination. But in case of inner join, you have to give the condition for combination. So in the inner join, you have to give the condition as inner join on course id is equal to prerequisite.course id. That condition is required to be given in case of inner join. So inner join is giving you only the common rows which are present in left hand side table or and right hand side table both. Only two entries are extracted in case of inner join. Look at this. Only two common entries are extracted. That is 1 and 2, which is present in this and this. So it is a inner join. In the natural join also these two will come, but in the natural join you need not to give the condition, but in inner join you have to give the condition. In the left outer join also, you have to give the condition for equivalence. It automatically does not do. If you light the natural join, left outer natural join, then it will do the naturally. Or if it is not natural keyword is not present, then you have to give the condition. Look at this natural right outer join. You need not to give the condition. Right natural join. We have explained it, so I will not be explaining you again. Full outer join, we have seen these 4 rows will come. So that is it for today. We will continue in the next class.